Hi students, today we are going to see an important topic in data structure called binary tree. So before going into binary tree, we will see the basics like data structure, types and the implementation process. So first the data structure means what do you mean by data structure? It is used to manage, store, organize and manipulate the data which is stored in the computer. So in this, the data storage is of two types. One is linear data structure and another is non-linear data structure. So linear data structure is the data will be stored in organized form from like one after another. Some examples of linear data structure is stack, queue, linked list. So inside linked list we have like many single linked list, double linked list, circular linked list. So these are the types of linear data structure. And one more important example is an array. So array is the best example for linear data structure. So next comes the non-linear data structure. In this the data will not be stored in one after another. The example for non-linear data structure is tree and graph. So in this video we are going to see one type of a tree called binary tree in detail, followed by binary search tree, and we have an important tree called as AVL tree, which is used to store the data very efficient way than binary search tree, which has some shortages. So now we will start with binary tree. So binary tree, the first definition of a binary tree is it is a hierarchical and non-linear data structure. So in introduction we have seen data structure is of two types, linear and non-linear. So this binary tree comes under non-linear data structure, that is the data will not be stored one after another. The hierarchical means we have no what I mean by the literal meaning of hierarchical is we have a root and we have a parent, so followed by there will be many children. So this is the meaning for hierarchical. So in this binary tree we is going to follow hierarchical and non-linear data structure. So in binary tree for every node there will be a two children, one is left child and another is right child. The left child and right child are the main concepts of binary tree. So this process is used for efficiently storing the data. After storage, it has to be properly retrieved from the database. So main application of this binary tree is mainly in databases, file system and searching algorithm, which all includes in which all includes in data storage and data retrieval process. So next we will go with important terminologies used in uh, and a binary tree. So first one is root node. The root node is called as the topmost node in a tree. The every tree will start with root node only. Next comes the parent node. The parent node is that which has two children, the left child and right child. Sometimes the parent node will also be there. If the parent node is at the start of the tree, then it is called as root node. Next comes child node. So child node is nothing but which have the parent are called as child nodes. Last one is leaf node. Leaf node is the one which has which does not have no children further. So it will have the leaf node will be having only the parent, not the children. Next is sibling node. So in sibling node is nothing but concept. They have single parent and they have a single parent. No sharing the same parent are called as sibling nodes. Next concept is level and depth of the root. So level means that a position of a node from the root. So next coming example we will be seeing in detail. So level is like the root is in first one or second one or third one. Last concept is height. The height is called as the longest path from the root node to leaf node. So these are the basic terminologies used. So as of now we have seen the terminologies. So with examples it will be very better to understand. So an example, and this is an example for a binary tree. The first one of the tree is called as root node. So for each node, root node, or it is also a parent of both child. So it is going to be called as a root node or parent node. So in this one we have both left child and right child. So left child and right child. So in this again they have a children node. So so this one second one is called as a parent node. So parent node is a children of a root node. So parent node again have a children node. So it continues further until it's a leaf node. So in last one if you see it is a leaf node. So leaf node is the one which have only the parent, but there is not any further children to them. So if you see the right side, depth 0, depth 1, depth 2, the starting first branch one is called as the depth 0. Next level of nodes are called as depth 1. So the edges is connected as in the for root node there is no edge connecting before. So that is 0. For second set there will be only one edge from root node to parent node. So the depth is 1. For child node if you see root node to parent node one branch, and from parent to child there is one edge. So the total length of the depth is 2. So next we will go with types of binary tree. So now we have seen what is binary tree. A binary tree is the one which have a root node and two children, and that followed by terminologies like parent, root, left child, right child, height, left children node, everything. So next we are going to see types of binary tree. So first one is full binary tree. In full binary tree, every node have either 0 or 2 children. That means it does not have one children at all. So it will have either no children or there will be only 2 children. That is called as full binary tree. Next one is complete binary tree. In complete binary tree, all levels are filled exactly at last level. So if you see that depth 1, depth 2, in depth 2 every parent will be having the equal number of child. So that is called as complete binary tree. Next one is degenerate binary tree. So degenerate means each node will be having only one child. So there will not be more than one child. So there will be either case like there is no 0 or there will not be no 2 child. Exactly it will be having only one child. So that is degenerate binary tree. Next one is perfect binary tree. A perfect binary tree is the one in which the internal node have only 2 children and all leaves are at same level. So there is the combinations of full and complete binary tree. That is, it all levels are at the same level comes under complete binary tree. So next, all internal node have 2 children will be comes under the full binary tree. So perfect binary tree is a combination of full and complete binary tree. Last one is balanced binary tree. So in this, the height difference between the left and right child should be always minimal. That is -1, 0 and 1. So for this we will have a diagrammatic representation. So if you see here, the first one is full binary tree. So in this full binary tree, it has either 0 children or there will be 2 children. So that is full binary tree. Next one is complete binary tree. So in complete binary tree is the one which in the tree will close it at the same level. If you see at the depth 2, all will be in the same level of depth 2. Next is degenerate. In this we see each parent node or child node will be having only one child. Each node will not be having more than one child. That is degenerate binary tree. Next one is perfect binary tree. So perfect binary tree is a combination of full and complete. That means each node will be having 2 children that comes under full binary tree. And second one is every level of the child will be at the same one, which is the condition of a complete binary tree. Last one is balanced tree. So this one is they will check the next income AVL tree will be seeing a balance factor. So we have to see the height of the tree, that is left child tree minus right child tree. The value of the balancing factor should be from -1, 0 and 1. So this will be seeing further detail in the upcoming AVL tree. Next one is tree traversal. So tree traversal. So we have now we have stored all the data in the form of binary tree. Next one is we are going to retrieve the data from the. For retrieving the data, the tree has to go in some way for searching algorithm. So for such type of searching, we have tree traversal. So tree traversal is the process of visiting every node in a tree at exactly once in a systematic manner. The systematic manner is the path in which it has to send. So in this traversal is used to access, used for searching, used to update the data and to process the stored data in the tree. So tree traversal is nothing but we are going to traverse the all elements of the tree or all nodes of the tree exactly once. So in this we have different types of tree traversal: pre-order, in-order, post-order, and last one is level order. So we will see now the pre-order traversal. In pre-order traversal, the condition is first we have to go to the root node, after that left and right subtree. So if you see the steps, first visit the root node, that is A, followed by traverse the left subtree, that is the B1. If you see the answer, that will be the root node will be an A, followed by root node B. After that, the traverse the right subtree, that is C. So in pre-order, left, first one there is root, next followed by left, and then followed by right. Next one is in order. So in order, the first root should be the left root, half left child root followed by right subtree. So first process is traverse the left subtree, that is B1. Next we are going to visit the root node, which is A, and we are going to traverse to the right tree, that is C. So in pre-order, if you see root, left, right, and in order that will be left, root and right. Next we are going to see post order. In this, the root comes at the end. So first we are going to see with left subtree, right subtree, then root. So if we follow the steps, first one is traverse the left subtree, that is B. Next we are going to traverse the right subtree, that is C, followed by the root node A. Now if you combine, we will have a revision like in pre-order, it will be root, left, right. In order, it will be left, root and right. And in post order, it will be left, right and root. So this is the tree traversal. If you want, we will go with an example. Now we will consider a tree. Now we will say an example for a tree traversal. So first one is, we will consider a node as A, B, C, D, E, F, G. So first we are going to see in order. Sorry, pre-order. Pre-order. So what is that? What does pre-order follows? A root followed by left followed by right. So if you follow this, the traversal will be first root is A, then we will go to left side. So in left, what is the root? It will be B. So after that, it will goes to left child of B, that is D. After that, it goes to the right of B, that is E. Now we have finished the left subchild. We have traversed root. Next one the left child. Next one is right of tree. Right of tree. What is the right of tree? Here the root right. This is the right subtree. In right subtree, the root node is C. After that, the left one is F, followed by right subtree. So this is an example for pre-order. So first one is A root. After that, the left child is B. So in B, D, E. After that, right C, F, G. So this is an example for pre-order. Next we will go with in order. So same example, A, B, C, D, E, F and G. Now first one is in for second one. We have seen pre-order, next in order. So in order is left, root and right. So first left one is this subchild. So in this, which is the leftmost root child, it is D. So first T traversal will visit the D1 because after D there is no child. So next one B, because left child is over. After that root node. After root we have to follow right side. So now we have finished only the left subtree. After that, that is root node A followed by right. So right order subtree is CFG. In CFG, the leftmost node is F. So after that it is F. After finishing left, we have to go with root node C. After that, right of root node, that is G. So this is the in order tree traversal. So in pre-order it will be like root left right. In order left root and right. Next we have to go with post order. So in post order, following by same example. Rule of our post order is left, root, right. So this is the condition for post order traversal. So in this post order traversal, first one is I am so sorry, I have made a mistake. Just a second. A small mistake. So first is left, then right, followed by root. So we have to remember only these things for in order, pre-order and post order. So first one is left tree. So we know that for first this is the root node. So we have to start only with left one. So in this left one we have to go with leftmost node, that is D. After that we should not go with root node. We have to go with right tree, right of root, then root. So first we are going with left one. In left one, the foremost left one is D. Next one is E. After that only we are going to with root B. After that we have to see a traverse through right node. So in right node, the leftmost one is F. After that it is G. After that the root node of right child is C. So we have traversed all the left subtree and right subtree. Then we have to go with. So this is the main differences between left, right, in order, pre-order and post order. Next one is level order. So this is the advanced one. So next one, level order is nothing but it will go with level wise traversal. So we'll put an example. Same one, A, B, C, D, E, F and G. So if you see this, the A comes under level 0. We have seen an example of we have seen a binary tree example. In that we will see an example like level or depth. In that example we will be marked as depth. So in this level 0, this is level 1, next this is level 2. So in definition for level wise traversal is, first at level 0 it will traverse to all the nodes. So in level 0 there is only one, that is root node. After that level 1 it has two nodes, that is B and C. So B and C, it will check for any other node if it's present in level 1. So in this case there is only two nodes. So after traversing to level 1 it will go to the level 2. So in level 2 it will go with D, E, F and G. So this is an it will check for other root elements in level 2, but there is no other further element. So this is the left level wise traversal. So it will go traverse through level wise. So this comes under the example for breadth first search. So this is an example for breadth first search. So we have finished now the concepts of tree traversal. Now we will have a quick revision of what we have seen up to now. So first we will went with what is meant by data structure is used to store and manage the data. So there is two types of storage in data structure. One is linear and non-linear. In linear that comes under array, linked list, stack, queue, and in non-linear there is only two types. One is tree and graph. So under tree we are now seeing the binary tree. In binary tree there will be a root node and child node. So for each node there will be only at most two child, that is left child and right child. So it is used for storage and retrieval of data. So main application is like database, file system and searching algorithm. So important terminology, root node, the foremost topmost node is called. Now after seeing an example you will be having a clear idea of these terms. So root node is the first one in the top of the tree. Next one is parent node. So parent node is the one which have the children. So whoever have children are called as parent node. So it need not be a root node. Then the child node. So the parent node connected to the before element are called as parent node. Leaf node is the one which does not have the further children. So siblings are the one which one have two both node which have the same parent, that is called as leaf node or sibling node. After that we have seen the level and depth like last example. So position of the node from the root one is called as level or depth. The last one is height. The longest path from root to leaf, the height alone we will see in the ABL tree example. So this is the structure of a binary tree. So types one is full binary tree which has either 0 or 2 children. The complete one will be always have the all leaf node at the same level. Degenerate means each one will be having only one child. Perfect is a combination of full and binary tree. So balanced binary tree is the one that the height of the difference should be from left and right should be of minimum. Either it should be 0, 1 or minus 1. This is an example for binary tree. Next we have see tree traversal. So types is preorder, inorder, postorder and level order. In preorder the traversal is left, root and right. In preorder it is root, left and right. In order it is left, root and right. And post order it is left, right and root. In level order means it should traverse through every level. So this all we have finished up to this. So next we will see binary search tree. So still now we have seen only binary tree. Now we are seeing binary search tree. In this there is only one difference between binary tree and binary search tree. The main condition of binary search tree is the one we have like left tree, right tree. See that key property last one. Left subtree should be less than root and it should be less than right subtree. So first we will see a definition. The binary search tree is special type of binary tree in which all node in left subtree contain values smaller than the root node. And then the right side subtree should be always greater than the root node. So very simple. I will give an example. So first we will go with the root node. Consider an example number 10. So in this number the left subtree, the left one should always be having less than 10 values. And then after that we will see right child. The right child value should be always having greater than 10 values. For example, now 5. So 5 always comes under less than 10. So it will be left child. Now if you are going to insert 2 and the 2 is less than 10, and if you go to 5 and the 5 will 2 is less than 5. So it goes to left one. After that now we are going to insert like 7. 7 is less than 10 but greater than 5. So it goes to right of 5. So we know the condition of a binary tree that every tree should have only at most 2 children. So it can have 0, 1 or at most 2 children only. After that we can't insert. Now in case if you want to going to insert 6, so it is greater than 10, greater than 5, so it need to go to right side. After that, but it is less than 7. So sorry, it comes under left of 7. Now if you are going to insert 15, it comes greater than 10, so it is 15. After that we are now considering inserting like number 12. So number 12 is greater than 10 but less than 15. So it goes right of 10 but left of 15. So that is basic property of binary search tree. Now we will go with the definition. You will be having some clarity. So see, in binary tree is a tree, is a type of a binary tree in which all node in the left subtree will be having values smaller than root node. We have seen an example like root node as 10 and smaller less than of 10 will be given to left tree. Then all the nodes of in the right subtree contain value greater than the root node. So everything will be having values greater than the root node. So both left and right subtree are also considered as a binary search tree. So for every insertion of the child node, it should be following the same process. So the tree property is left subtree should be less than root node and right subtree should be greater than root node. So this is the basics of binary search tree. Next is characteristics. So what we have seen last example only, each node will be having at most 2 children only. This is the basic condition for binary tree. So all binary tree should have only most of only 2 children, because that is the name reason of the binary. Binary means we know only it have 2. So it has only the left child should be smaller than the parent and right child should be greater than the parent or root node. So this also very useful for searching, insertion and deletion process. So in this we have seen traversal like 3 traversal: inorder, preorder and postorder. So in this the process, the traversal implemented in binary search tree is in order. The in order means left, root and right. So the traversal followed in binary search tree is first it will go to the left subtree, then root and then it will go to the right subtree. Insertion. So we have to start with the root node, compare the new value with the current one. So if it is smaller, we will move to the left subtree. If greater than, we will be moving to right subtree. So repeat the process until empty. So inserting a new node. So these steps we have seen already saw in the example already. We can see one more example also. So now we are going to see an example for the binary search tree. So starting with, we'll give some random numbers. So we'll start with 20, 10, 30, 40, 5, 35, 25, 7, 9. So first, for whatever node comes first, consider as a root node. So after that, the number is 10. We have to compare. If you see, the first one is considered as root node. Next, whatever comes, we have to compare with the root node. So now 10 comes. So 10 is the value less than 20. So it goes to left child. After 30, 30 is greater than root node, so it goes to right of root node 20. So we have finished this. After that 40, so 40 means it is greater than 30. So we have finished. Next 5. 5 is less than 20 and less than 10 also. So we can't insert 5 in the along with 20 because the condition of a binary tree is that it has one, it need to have only 2 children. So it can hold only 2 children. So after 20 we have to go to 10. So 5. After that 35. 35 comes greater than 20, greater than 40. So we can't go greater than 40 but less than 40. So because 35 is less than 40, we have to insert it the left of 40. Next is 25. If in case of 25, it is greater than 20 but less than 30. If you see 30, the 30 has only one children, that is 40. So you can insert 25 here. So 25. Then it is 7. So 7 is less than 20, less than 10 and less than 5. So less than 10 but greater than 7. So 7. Next is 9. 9 is 20, greater than less than 20, less than 10, comes under 5, greater than 7. Because we can't insert in left side subside because 9 is greater than 5. So it has to go as right of. So this one is an example for binary search tree insertion. So nothing but first we are going to consider the root node. Whatever node we are going to insert, we have to check with the child node. If it is smaller than, it will go to left child. If it is greater than, it will go to the right child. So we have to continue until we have inserted all the elements. So with this we will see the complete the basics of binary search tree. So in this slide we have seen binary tree. What do you mean by binary tree? Terminologies, important terminologies used in binary tree. Next, types of binary tree, followed by tree traversal. So this is the very big important topic for any questions like 13 mark everything. Next one is binary search tree. So binary search tree is an advancement of a binary tree. So in next video we will be seeing about ABL tree. So which have advantages of binary search tree. Thank you.